Good morning. I'm B. Karkurli, Assistant Professor working in Triple Department RMDEC. The topic today I'm going to take is from the subject Basic Electrical and Electronic Measurement, whose subject code is B8255. And the topic that I'm going to cover in the Unit 1 of B8255 Basic Electrical and Electronic Measurement is Kirchhoff's current law and Kirchhoff's voltage law. So these are all denoted as KCL and KVL. So these are the laws that are used to find out the current and the voltage across any circuits. Okay, so it was given by the scientist called Kirchhoff's. Hence the name Kirchhoff's current law and Kirchhoff's voltage law. He was the one who has defined all this. Okay, now coming to the Kirchhoff's current law. So or it is also called as KCL. So what does KCL states? The sum of the current entering into any node is equal to sum of current leaving that node. Okay, the sum of the current entering any node is equal to sum of the current leaving that node. So if you see, this is the node. What is a node? A node is a small junction of where the current meet each other, or where the currents leave or enter inside a point. That is the junction at which the current enters or leaves the node point is called as a node. Okay, so this is called as a node. Let this node be 1. Okay, so in this node 1 we can see these are all called as branches. Okay, so this dot is called as the node and these are all called as the branches. So totally how many branches are there? 7 branches are there. You can see totally 7 branches are there. So from this point node, 7 branches leave, and in the 7 branches some currents enter the node 1 and some current leave the node. Okay, so now let the current flowing through every branch be denoted as I1, I2, I3, I4 and I5 and I6 and I7. So I can see that current entering here, I1 is entering, I2 is also entering, I4 is entering and I7 is entering. Okay, I3 is leaving, I5 is leaving and I6 is leaving. Okay, so we can say the algebraic sum of that is the sum of the currents entering into any node is equal to sum of the current leaving that node. So that is what Kirchhoff has defined. Okay, so we can say that the current entering the nodes on the left hand side and current leaving the nodes on the right hand side. So I1 plus I2 plus I4 plus I7 equal to I3 plus I5 plus I6. And we can also say Kirchhoff's current law is algebraic sum of the current and across a node. That is algebraic sum of a current in any node is equal to 0. Why? Because I can also write this as I1 plus I2, because the current entering on all one side, that is I1 plus I2 plus I4 plus I7 I can remove, I can get all the currents, that is I7. Okay, so this is current is I7. So I can write it as I7. Now get all the other currents this side. So minus I3, minus I3, minus I5, minus I5, minus I6 is equal to 0. So I brought all the currents to one side and I equate it to 0. So this is called as algebraic sum of the current. So KCL can also be defined as algebraic sum of the current entering, algebraic sum of the current across a node is 0. Okay, so that is what Kirchhoff's current law states that. I'll just use this option so that you can clearly see this. Okay, so this is the algebraic sum of the current across a node is 0, or current entering the node is equal to current leaving the node. Okay, or I can also write it as I1 plus I2 plus I4 plus I7 minus I3 minus I5 minus I6 is equal to 0. So this is what Kirchhoff's current current law. We'll see an example here. So there is a voltage source with three resistors that are in parallel with each other. You can see the current that is entering here is called as the total current IT. So this current is nothing but the total current IT. Now this current, there are three resistors. These three resistors are parallel with each other, and the current entering is going to divide here into three parallel branches across the three resistors. So let this resistor be 1, this resistor 2, and this resistor is 3. Okay, the current entering through the resistor 1 is called as I1, the current I2, and the current entering through the resistor 3 is called as I3. Now this is the node. Okay, so the current here it is entering, and from this node there are three different branches where the current leaves, and there is a single branch. So totally there are four branches in a node. The current leaving the branches are called as I1, I2, and I3, and the current entering the node is called as the total current IT. So if I apply Kirchhoff's current law in this node 1, it is given as the current entering the node is equal to current leaving the node. So the current entering the node is IT. Okay. So IT is equal to current leaving the node I1, I2, and I3. So I1 plus I2 plus I3, or I can also write it as IT minus I1 minus I2, because I'm getting all the currents to the other side. So minus I2 minus I3 is equal to 0. So this is called as algebraic sum of the current entering, and algebraic sum of the current in a node is 0. Okay, so this is what is called as Kirchhoff's current law, and this will be used to find out. So this is the total current, and this will be used to find out your current flowing through any of the circuits. This is a small circuit, so even you can find out current flowing through across any circuit, that is in any branch. Mainly, Kirchhoff's current law is used to find out the current flowing in any branch of an electrical circuit. Now, Kirchhoff's voltage law. So, what did Kirchhoff's voltage law state? It states that the algebraic sum of the voltage in a closed path is zero. That is, the voltage in a closed path is zero, which means that the voltage that is being supplied. So, this is the main source. Okay, this is the active element that we have seen. So, this is the voltage source. These three resistors R1, R2, R3 are the dissipating. They take the energy from this voltage and they dissipate the energy in the form of heat. So this is giving out the voltage. So voltage source gives out sources the voltage, and the resistors, what it does, it takes the voltage from the voltage source or the energy from the voltage source and dissipates the energy in the form of heat. So how does it take the voltage? It takes the voltage in the that is, it takes the energy in the form of V1 into I1. Okay, so Vi is equal to R. So that is what is given by Ohm's law. So the voltage across the resistor is V1. The voltage across resistor, voltage across, we always say voltage across because it is across these two ends. Okay, so the voltage across these two ends. So if you see here, it across these two ends is V1, here it is V2, and here it is V3. So I can say that the source voltage Vs is equal to Vs, source voltage Vs. Yes, Vs is equal to V1 plus V2, the voltage across the resistor 1 plus V1 plus V2 plus V3, and the current flowing through the resistors. All the resistors are connected in series, so the whatever the current that flows through R1 also flows through R2, and also it flows through R3. So the same current flows through R1, R2, and R3, and it is given by total current I. Okay, so the current is going to remain the same, and sum of the voltages is equal to 0 means what? Vs minus V1, that is like similar to KCL. Vs minus V1 minus V2 minus V3 is equal to 0. Okay, so this is the algebraic sum of the voltage is equal to 0, which is given by Kirchhoff's voltage law, and algebraic sum of current is 0, that is given by Kirchhoff's current law. Okay, now, or we can also write as sum of voltage rise is equal to sum of voltage drop, because here this is the source voltage, this will give the voltage, and these are all the one. Here the voltage drop occurs because the energy that is stored is getting dissipated in the form of heat, so automatically voltage drops. So voltage rise is seen here. In voltage source you can see voltage rise, and across the resistors you can see the voltage drop. So I can change the color and give, so that you can clearly understand. So this is the voltage source, that is voltage rise. So voltage rise is seen here, and across all the resistor elements you can see the voltage drop. Okay, voltage drop is seen across all the resistance elements, so I can write it as Vs is equal to V1 plus V2 plus V3, or the sum of the voltage rise in a closed path is equal to sum of the voltage fall in that closed path, and it is given by V1 plus V2 plus V3. We know that according to Ohm's law, V1 equal to IR1, V2 is equal to IR2, and V3 is equal to IR3. So I can write it as, take the current outside, which is constant, give, open the bracket, R1 plus R2 plus R3. Okay, since the, so sum of the resistance, all the resistance are connected in series, so R1 plus R2 plus R3, the entire sum of all the resistances is called as the effective resistance or the total resistance. Okay, so this is R1 plus R2 plus R3. R1 plus R2 plus R3. Okay, so we can see that for the source, from the positive terminal, current always flows from higher potential to lower potential. So current always, whenever there is a circuit, we always write the current flows from higher potential to lower potential. So positive is the higher potential and negative is the lower potential. So wherever the voltage source is, that the current direction has to be assumed that the current leaves the positive terminal and it reaches the negative terminal. Okay, and similarly for an resistor, the current enters in the positive terminal and leaves the negative terminal. Okay, so current enters into the positive terminal and it leaves the negative terminal. So we will take a problem and we will find out what is the total voltage. Okay, the total or the total voltage is given. What is the question given? For the circuit shown, determine the unknown voltage drop V1. So we are going to find out the voltage drop V1. So this is the voltage drop. This is the question that is asked. So the resistor, this is the resistor, and we are going to find out the voltage drop across this resistor. Okay. So in this resistors, we can see that. So this is the question that is asked. Okay. So this is, we are going to find out the voltage drop across this resistor. Okay, now we are going to apply KVL as we know. And what is the KVL? We source voltage is equal to, so source voltage is equal to sum of all the voltages. So totally how many resistors are there? 1 2 3 4 5 resistors are there. So Vs is equal to this voltage plus 2 volt, that is 30 is equal to 30 is equal to 2 plus 1 plus V1 plus 3 plus 5. Okay, algebraic sum of the voltage, same current I flows. And we denote everywhere the sign. The current always flows from higher potential to lower potential. So this is what we said. The current flows from higher potential to lower potential. Okay. So the current always flows this way. It flows this way, and then it ends the circuit. So KVL is applied only for closed path. So the path should be closed. When there is an open path, the current does not flow, and KVL cannot be applied there. So 30 is equal to the sum of all the voltages, from which we find out that the voltage V1 is equal to 90 volts. So this is the basic explanation for KCL and KVL. Thank you.